Hey everyone, welcome back. Before we begin here today, please make sure that you like and subscribe because it really does help out our channel and it also helps us reach others in need of assistance with these topics. So in today's video, we're going to be looking at statics moment about a point, and this will be our sixth part in this particular series. So what we have going on here is that for the bracket pedal shown here on the left, we need to determine the magnitude and the direction of the smallest force P that has a clockwise moment of 104 Newton meters about point B. So what we have going on here is that we have this moment that is clockwise of 104 Newton meters, which is just simply, since our units are in millimeters, is 104,000 Newton millimeters of clockwise moment. And we have to determine what is the smallest P, and we have to determine that angle in which it's acting off the horizontal. So if we look at moment, the equation for moment is going to be force times a perpendicular distance. So if we want the smallest force possible, that means we have to use the largest distance possible in order to create that same moment. So as our force decreases, our distance must increase to create that same moment. So what this means is that we have to determine the largest dimension possible that P can have. So the largest dimension away from B would be this dimension right here, from B to A, that direct line. So if we write this out in somewhat of a geometry format, it would look something like this, where this would be 100 millimeters, and this is point A, and this is point B, and this would be 240 millimeters. So basically I made this little triangle right here out of our dimensions. And this would be my distance that I can have. That's my largest dimension. Well, that D, that dimension is pretty easy to get because this just forms a right triangle, so we can use Pythagorean theorem here. So this would just be 100 millimeters squared plus 240 millimeters squared, square rooted, and this gives us a distance of 260 millimeters from a direct line from P, or from A to B, where P is acting. So that's the largest dimension we can have. Alrighty. So we also have to determine what this angle of alpha is. So let's go ahead and let's determine this angle of theta right here. So if we look at our triangle, this is what we have going on here. So we have this portion and then this vertical portion right here, and we just determined this hypotenuse side here, and then theta is right there. So let's determine what theta is. Well, theta is pretty simple to get here, just using trig. It would be the tangent inverse of 240 millimeters over 100 millimeters, and that gives us an angle of 67.38 degrees. So why did I go ahead and find theta? Well, if we are utilizing our dimension D here, which is the 260 millimeters, because we need a perpendicular distance here for P, that means that that angle has to be 90 degrees. Well, we have already found out that this angle is alpha, as shown up here off the horizontal. That's the angle we're looking for. And we just found that this angle right here is 67.38 degrees. So in total, what we would have is that alpha plus theta would need to be equal to 90 degrees for that perpendicular dimension to occur to 60 between P and point B. So that means that our alpha would essentially be 90 minus theta, which is 67.38 degrees. So that means that our alpha angle would be 22.62 degrees. And there's one of my answers. So just because of this equation up here, that dictates what our dimension, our maximum perpendicular distance needs to be. And because it has to be at 90 degrees, that also dictates what alpha has to be. Alrighty, so now we can get P if we determined our angle. So what we're going to do is we're just going to use this equation right here. And our moment is 104,000 Newton millimeters must be equal to our P force times our perpendicular distance, which would be 260 millimeters. So you just rearrange for this, and then our P force pops out to be a nice 400 newtons in that downward right direction. So this would be my final answer. I found the magnitude of the smallest force possible and the angle in which it has to occur, just utilizing geometry and trigonometry, realizing that it needs to be a 90-degree angle occurring between my distance and my force, and that the largest distance possible creates the smallest, or utilizing the smallest force possible, then in conjunction with that creates the same moment. And that's how you would solve that particular moment problem. So I hope this video was helpful, and if you want to see more problem solved this Friday, please check out the other videos on our channel. Also, if you've done so already, please like this video, leave a positive comment below, and subscribe to the channel because all of that does help us out. Thank you for watching, and I hope you have a fantastic day.